Hello guys, welcome back again to my YouTube channel. So if you wanna look for the values of k as shown on the thumbnail, you can skip right straight to question 8.3. I think I did some chapters there to show you the 8.3. But then if you wanna watch the rest, you can start with me as of now. And then so now we are going to be doing cubic functions, and then so we are going to be doing a lot of stuff. So now firstly here we are given the equation of f is equals to negative x cubed plus 6x squared minus 9x plus 4. And then they say that this is also equivalent to x minus 1 squared into negative x plus 4. So basically this form is the same thing as this, it's just that they factorized it to become like this. So now what you must also notice is that if ever you have a factor which is a square like that, you must know that you're going to have an x-intercept which is also acting as a turning point. And then another thing which I want us to put emphasis on is the value or the coefficient of x cubed. So you see the coefficient of x cubed is -1. It's there, but it's not there. So now what does the coefficient of -1 tell you? It tells you that your graph is gonna start down, then it's gonna go up like that. So now we are gonna use all of this information to help us answer the questions here. So now we are gonna start with 8.1. Then they say determine the coordinates of the turning points of f. So now the turning points of f are here and here. So now what you know about the turning points of f is that the gradient at this turning point is 0. The gradient here is 0. And how do you find the gradient of a graph? You find the gradient of a graph by the first derivative. So basically the first derivative of f is going to be equals to, you're going to derivate or differentiate this equation, is going to be negative 3x squared plus 12x minus 9, right? Yes. And then so now that you have differentiated, this equation is an equation which gives you the gradient of f, of our function f at any point on the graph. So now what we are looking for, we are looking for those x values which the gradient of the graph of f is 0. That means that your f prime x must be equals to 0, and then therefore, which means that negative 3x squared plus 12x minus 9 must be equals to 0. And then if we factorize this, we are going to get this, right? Because the 3 with this negative over here, and then over here going to be left with the -4, over there going to be left with the +3. Then you divide by -3 on both sides of the equation such that you are left with x squared minus 4x plus 3 equals to 0. And then now you factorize this is going to be x minus 1 into x minus 3 is equals to 0. Thus x equals to 1 or x equals to 3. So now what does this tell you? It tells you that on my graph here is an x value of 1, and over there is an x value of 3. And now I'm looking now for the corresponding y value of that x value, because they say that we must find what? Coordinates of the turning points. They didn't say find x values of the turning point, find coordinates. So coordinates, you have an x and a y. You guys write like this, but then yeah, where I am, you write a thing, a comma in between. So now what you're gonna do is that you're going to substitute this x equals to 1 into the equation of f, and then this x equals to 3 in the equation of f. So now I'm going to substitute them. So you're gonna get that f into 1 is equals to -1 cubed plus 6 1 squared minus 9 into 1 plus 4, and this gives you an answer. You're going to get f into 3, which is going to be equals to negative into 3 cubed plus 6 into 3 squared minus 9 into 3 plus 4. And then you use your calculator, because just to avoid error, -9 plus 4, and then over here we have 0, and then you're going to have -3 all cubed. We're going to have 3 cubed, which is a negative. So it's -27 plus 6 into 3 squared minus 9 into 3 plus 4, which gives us a value of 4, like that. So then what we have is that therefore the coordinates of the TP are, so you have a 1 and a 0, then you have a 3 and a 4, right? So now 8.2, they say that sketch a graph of f, and then they say that clearly label all the intercepts with the axis and any turning points. So now they say label intercepts with the axis. They mean the x-intercept and the y-intercept, right? So that must be shown on your graph. So what do you need to draw a graph exactly? You're going to have to find your x-intercept, whereby your y value is equals to 0. You're going to have to find your y-intercept, whereby your x value is equals to 0. And then you're just going to use that to piece up your function, right? So now what you're going to start by finding, we're going to start by the x-intercept. So this is the equation of f. So now we are going to use this small part over here, because this is still f, right, to equate it to 0. So we're just going to say f of x is going to turn into 0, and it's going to be equals to this part, right? And then you're going to find the what? The x-intercept. Okay, now we're going to have x minus 1 all squared into negative x plus 4, and then this is going to be equals to 0. And then you're going to solve, right? So you're going to get x minus 1 all squared must be equals to 0, or negative x plus 4 must be equals to 0, which means that your x must be equals to 1, or your x must be equals to 4, because that one, when it goes to that side, becomes a negative. You divide by negative on both sides, then you're going to be left with positive 4. And then now as we continue, we're looking for the y-intercept now. Now we know that our x-intercept is x equals to 1 and x equals to 4. And then now as for our y-intercept, you're going to let our x be 0. So we have the equation of f, which is f of x equals to negative x cubed plus 6x squared minus 9x plus 4. So already you can see that this is your y-intercept, but just to make that clearer to you guys, we let x be 0. So you're going to have a 0 there, and you're going to have a 0 there, you're going to have a 0 over there, you're left with 4, and all of this is going to be 0. Then you're going to be left with f of 0 is equals to 4. And already you know that your turning points are, as we have found over there, it's 1 and 0, and what? 3 and 4, right? So now what I want you to notice is that 1 and 0 over here is acting as a turning point, and is also acting as an x-intercept. Isn't that amazing? That was because over there we had x minus 1 all squared, which was already predicting to us that we're going to have a same 1 point, which is acting as an x-intercept and as a turning point. So now as we draw our stuff, you're going to have something like this. Just make sure to use a ruler, like that, and like this. And another thing, you know how already your graph is supposed to look like? It's supposed to look something like this. Right? Just because you knew that a was less than 0, you could already predict that the shape of your graph is going to start down, then it's going to go up. So now, what we are going to have now is that we are going to plot our points, right? So we have the y-intercept. Let me just extend over here as 4. And then we have the x-intercept, the first one, as 1. Then the second one as 4. So now, like, it's just an estimate. Like, you don't have to draw it up to scale that much. And then so now you're going to plot your, what's this, your turning point, this point over here, which is going to be 3 could be somewhere here, and then it's going to be, yes, 3 and 4. And make sure you indicate which point it is, and then you know that you're going to join your points like this. Forgive me for not joining properly over there. And then, yeah, something like this, like that. And then it just goes up to infinity over there. Then it goes up to infinity over there. And then, so let me just, yeah, just to make it look a bit more nicer. Yes, and that's our graph. And then, so now we are starting with 8.3. Let me just move this stuff. What am I doing? Forgive me. So now 8.3. Use the graph to determine the values of k. Use the graph to determine the values of k for which negative x cubed plus 6x squared minus 9x plus 4 is equals to k will have 3 irreal and unequal roots. So now these are a certain type of questions. They differ in their types. They're not always, the approach is not always the same, but then there are certain types whereby the approach is the same. So now in this special case, we have a value of k equals to the original equation. If you check, our original equation was this, right? So they are saying that use the graph which you have just sketched to determine the values of k. So now what is k equals to? K is equals to our equation of f of x, right? So that means that we are using the graph to determine the values of k, the values of f, the y values exactly. So when they say the values of f, they mean the y values. What do I mean by y values? I mean these values like this. These are the y values which exist on the graph of f. So I'm just going to draw a lot of them just to like that. Yes. So now you're looking for the y values or the values of k. I'm saying y values because k here was equated to. There are some instances whereby you're gonna get a plus k on the left hand side, whereby you can't really interpret k as y values. But in this case, we can interpret our k as y values. So now we're looking for those values of k. So these are the values of k. This is k equals to something, k equals to something, k equals to something, k equals to something, k equals to something. So these are the values of k for which our graph will have 3. So now we're looking for the values of k, which our graph will have 3 real and unequal roots. So now real just means that they exist, and then unequal just means that they're not the same, and the roots just means x values. So looking for those values of k which correspond to 3x values. So what do I mean? So now look at this value of k, right? It cuts the graph 1, 2, 3. So that means it has 3 values. You go like this, cuts the graph 1, 2, 3, right? 1, 2, 3. Okay. If I just draw another one, 1, 2, 3. So you see the graph twice. But then as soon as you get the turning point over there, it only cuts how many times? 1, 2. Okay. And as soon as you get that turning point, it only cuts how many times? 1, 2 times. So that means that these values of k have 3 real roots in between this and this. So in between here, that's where we have values of k which correspond to 3x values. Because now if you go above the turning point like this, it only cuts it once. And if you go below this turning point like this, it only cuts it once over there. But then we are looking for those values of k such that it shall cut how many times? 3 times. So what you are gonna do is that you're going to say it's for those values of k which are between this y value, and the y value here is what? Is a 4. And between this y value and the y value here is what? Is a 0, because that's the x-axis. So that means that's going to be for k's between 0 and 4. And we don't include 0 because at 0 it only cuts it twice, and we don't include 4 because at 4 it only cuts it twice. But as soon as you go below 4 like that, it cuts it 3 times. And as soon as you go above 0 like that, it cuts it how many times? 3 times like that. So that's the answer there. That's for 8.4. We're given the line g of x equals to ax plus b is the tangent to f. So this is a straight line equation, and it's a tangent to f at the point of inflection of f. So now what's the point of inflection? So the point of inflection is where our graph changes concavity. So what is concavity? Basically, it's just a simple way of saying it is facing up and it is facing down. So now you see here, up until this point, your graph is facing up, right? Then there's a certain point here. That point is called a point of inflection, whereby the concavity is going to change. It's no longer going to be concave up, but it's not going to be concave down. So now they're telling us that G is a tangent at this certain point over there. So now let me just draw a rough sketch of going to be something like this. So now you see it's a tangent to the point of inflection, and they say we must find the equation of G. So now finding the equation of G, you're just basically finding the equation of a straight line. And you know how to find an equation of a straight line. All you need your gradient, and you need one point which you can substitute in x and in y such that you can get b, right? So now, our equation is g of x equals to ax plus b. So let's start by finding the points x and y. So we know that our graph of G is a tangent at the point of inflection. So now let us find the coordinates of the point of inflection. So one thing you must know about the point of inflection is that it is where the second derivative is equals to 0. So you know there's a first derivative, right, over here. And then now we also have a second derivative. That's what you're going to do. So we're going to say second derivative of f is equals to, the reason why I'm finding the second derivative of f is because that's where the point of inflection is. It's on the graph of f, and where the second derivative of the graph of f is equals to 0. So now f prime prime x is going to be equals to negative 6x plus 12 based on this equation, right? Just gives you this. And then so now what we're looking for is where f prime prime x is equals to 0. Then it's negative 6x plus 12. Then you're going to get your x equals to 2. Isn't that amazing? So now which means that over here, this corresponds to an x value of 2. Right? But then we still need to find the y value of this x value. So now to find the y value of this x value, we substitute into the original equation. Okay, and then so now our original equation is f of x equals to negative x cubed plus 6x squared minus 9x plus 4, like that. We're going to have f into 2 equals negative 2 cubed plus 6 into 2 squared minus 9 into 2 plus 4. And then you're going to get negative into 2 all cubed plus 6 into 2 all squared minus 9 into 2 plus 4. And this gives me what? 2. Oh my gosh. And then so now that means that over there you have the point 2 and 2. Wow. So now basically, which means that our equation of G intersects the value 2 and 2, right? And now we are looking for the gradient of G. So now basically, because the graph of G is a tangent to the x value of 2, you know how at a point you can have a gradient, right? Using first derivative. First derivative, remember I told you that it gives you the gradient at any point on the graph. So now what I'm saying is that we can find the gradient at the x value of 2. And that gradient at the x value of 2 is going to be the gradient of the graph of G, because the graph of G is a tangent at the x value of 2, where at the x value of 2, the gradient is going to be a certain number. Yeah, but that's just that. Wow. Okay, so now let's go to f prime x. So now f prime x, we have found it over here. F prime x is equals to negative 3x squared plus 12x minus 9. So now we're going to look at for the gradient at the x value of 2. So which is going to be f prime into 2, which is negative 3 into 2 squared plus 12 into 2 minus 9. So you're going to have negative 3 into 2 squared plus 12 into 2 minus 9. Then you get, wow, amazing, everybody, you get 3. So now basically, now the gradient at the x value of 2 is 2, and this gradient is the gradient of G. So therefore, in your equation of G, you're going to have a 3x plus b, because the gradient of f is represented by this a over there. So now what we're going to have now, we are going to substitute those points which we found. We found that the point of inflection of F was actually 2 and 2, right? So now we are going to use that to our advantage and substitute it into this graph. So we are going to sub 2 and 2. So basically this is going to go over there and this is going to go over there. So I mean, like, you're going to substitute into this. This 2 is going to replace this, and this 2 is going to replace this. So you're going to get 2 is equals to 3 into 2 plus b. Therefore 2 is equals to 6 plus b, and b is equals to negative 4. So now therefore g of x is equals to 3x minus 4. Okay, yeah, okay, that's weird. And then so now we go to 8.5, whereby they say calculate the value of theta, the acute angle formed between G, our equation G, and the x-axis in the first quadrant. That's theta over there. So now you're gonna say this is your theta, and then you know that theta is just basically the angle of inclination, right? So now you know from analytical geometry that the angle of inclination is equals to, well, the tan of the angle of inclination is equals to the gradient of our graph. So what I'm saying is that for your 8.5, your tan of theta is going to be equals to 3, right? Which is the gradient of G. And therefore theta is going to be, you can say shift tan theta, I just like to say arctan 3, you can say shift tan 3, I just like to say arctan 3, and therefore your thingy is going to be 71.57 degrees. And with that, thank you everybody for watching, and don't forget to subscribe. Yes, and I'm signing out. Sharp.